Lesson 47 is short and sweet. It deals with the two types of waves that we're going to be discussing in Physics 20, and those transverse and longitudinal waves. And transverse waves are really easy to see because basically if you take a rope or a slinky and you just shake it up and down, then this is the kind of wave that you get. This is a transverse wave. Oops. And it's transverse because the particles of the wave, like these are all different particles on the slinky, which way are they moving? And the answer is they're moving up and down. So if I'm shaking this slinky and just watch a video on shaking a slinky or something like that, or get a slinky, get a rope, shake it up and down to make this wave pattern, the particles are moving up and down. But which way am I transferring energy? And the answer is that way in this case. If I'm holding the string here and then I start shaking it, we can have a PhET demonstration. We'll get to it in a minute. Then the particles are moving up and down, but the energy is being transferred in this direction here, right? So that if I start shaking it here, the energy will be transferred all the way over to here. And here's the key point right here. The particles of the medium move perpendicular to the distance, to the direction the transwave itself is moving. Okay, and then it says the best examples of transverse waves are plucking the strings on any stringed instrument. Longitudinal waves are a little more difficult to see visually, but they're really important because sound is all longitudinal. So if you take a slinky and you compress this point here and then you let go, what happens? That compression goes this way, and as it compresses this in this direction here, it expands behind it. So you get this constant compression, expansion, compression, expansion. But again, the energy is being moved in that direction here. So in this case, the particles, so if I had a particle on the slinky right here and I stretched it, what would I see it doing? I'd see it going back and forth. So they are going back and forth, left and right, and the direction of the wave here is to the right. So therefore, the direction that the particles are moving is parallel right here to the motion of the wave. And then it says the best examples of longitudinal waves are sound waves. I should have set this up before, but let's quickly go on to a quick PhET demonstration. PhET, go on to Google PhET, physics simulations, and sound and waves, and where is the one I want? Wave on a string. Wave on a string, download that. Okay, so here's a quick one. I can't show this too long because again, it takes up too memory. So here's a, let's just oscillate this. There we go. There is a wave on a string, and you can do all kinds of crazy things with this. You can make it a pulse. So if I make it a pulse, it's just going to send a pulse on over the string, and I can have no dampening so that it's going to send it there, and then it, look at that, it comes back, and it's inverted when it comes back. Why? We'll discuss that in future lessons. You can do all kinds of crazy things with this, make all kinds of neat shapes, standing waves, and everything. That's that. That's the end of that lesson. We'll see you for the next lesson.